Hi everyone, welcome back to my channel. Today we are diving into configuring internal DHCP server on 9800 controller. I'll walk you through the step-by-step process. How do you configure internal DHCP server? What are the configuration steps? So the topics which I'll be covering here, the very first thing we will try to understand a DHCP traffic flow with a wireless client. The second topic would be configuration steps in wireless controller. Third one is data collection and analysis. Fourth one is verifications. And the fifth one is best practices. Because the best practice is also important to understand where to use internal DHCP server functionality on 9800 controller. What are the best practices while considering this particular feature on 9800 controller? Let's understand the DHCP traffic flow with the wireless client, which is again DORA process. So very first packet is a discovery packet which will be initiated from client. So client would send a discovery packet with the source IP address at 0.0.0.0 with the destination as a broadcast, which is 255.255.255.255. When it hits to the access point, in my case, access point is configured with the local mode. So access point would encapsulate that original discovery packet in a CAPAP tunnel with the source IP address as 30.11 as outer header, which is my CAPAP header. And the destination is my controller IP address, which is in my lab, it is 40.230. When it hits to the controller sees, okay, this packet is a discovery packet and it has come from WLAN 60. Now from where controller gets the information about WLAN 60, that's again what you configured under policy profile, which is mapped to the policy tag along with the WLAN profile is nothing but what WLAN you have configured. So that will hit to the WLAN 60. Controller would decapsulate it, make the DHCP offer with a source IP address is my SVI of WLAN 60. So in my case, it is 192.168.60.10 and the destination is actually my client IP address. So it could be 60.12 or 13 or 14, whatever IP address controller is trying to hand off. So that particular packet would be encapsulated by controller with the source IP address in this case now is my controller IP address and the destination is access. After that, the controller sends that packet to access point. Access point would decapsulate and send it across to the original client which is trying to get the IP address. Now once the client gets the DHCP offer, the client try to send a DHCP request packet here with the source IP address as again 0.0.0.0 and the destination is broadcast. Now here, imagine you are going into the coffee shop and barista asks you your name, your favorite coffee, your mobile number, and when you go next time into the same coffee shop, the barista would know which is your favorite coffee. So without even asking which coffee you want to order, they would try to offer you your favorite coffee. So the same way, DHCP handshake, or let's say the DORA process, is trying to collect the information of the client. So here in this case, DHCP options are nothing but the information which has been collected during the initial handshake, which includes option 50, for example. Like after the offer message, DHCP request packet would have option 50 as your requested IP address, and that requested IP address is already been given as a part of DHCP offer. So even though you see source IP address as 0.0.0.0, your requested IP address is a part of request packet. Now that packet goes to the access point. Again the same process. Access point would encapsulate that packet with the outer header as a CAPAP header. Goes to the controller. Controller sees that it is a DHCP request. The requested IP address is whatever IP address was offered originally from controller. Controller would reassemble the packet and would make as a DHCP acknowledgement with the source IP address as the client SVI, let's say it's a gateway, that would send across with the destination IP address, whatever IP address was as a part of option 50. Now that packet would go across to the access point, and access point send it across to the client, and that's how the handshake happens. So in my lab, my access point IP address is from VLAN 30, which is 192.168.30.11. My controller IP address is 40.230, and the client is supposed to get IP address from 60.x, which is from VLAN 60. I would be excluding some range which I have mentioned in this table, and my gateway is not 1, in fact it is 60.10. So my gateway IP address is 60.10, and DNS server is 192.168.100.253. This would be my configuration. So as you can see, I would be creating a DHCP pool. I would exclude some range from that particular pool. I would configure default router as 60.10, DNS server as 100.253, okay, and the SVI obviously for VLAN 60. And if you want to configure through GUI, you have an option in GUI under the administration main tab. If you want to create, you can create through GUI with the DHCP pool. Same options: IP address, let's say IP type, subnet mask, lease, starting IP address, ending IP address, and the CLI I have already shown here, how the configuration would look like. Now, what data we are collecting to analyze? So we are going to collect the radioactive trace. We are going to collect the pcap on the controller, which is embedded pcap. We are also going to initiate a debug on the access point CLI, which we will be collecting. And then we would also do the packet capture from client, so that we have end-to-end data to analyze and understand how DHCP works when it comes to internal DHCP server. When it comes to internal DHCP server configuration, keep in mind whatever maximum scale you have based on the hardware. Let's say 9840 has a maximum capacity of 32,000 clients. 20% of that capacity is what you would get from internal DHCP server. In this case, it's 6,400 DHCP binding. Okay, the second best practice is you need to configure SVI and set the IP address as a DHCP server IP address. Okay, so under the SVI, you are going to configure DHCP server IP address. Then you have another best practice, or let's say it's something limitation, I would say. When you configure internal DHCP server on the controller, let's say controller reboots, the addresses are not going to get preserved. So that means multiple clients might end up getting the same IP address. To resolve that conflict, you need to go back to the client and release and renew the IP address. That's one of the limitations. That's why I would say this is good if you are using for small scale with the guest SSID. The fourth is VRF and DHCP v6 are not supported on internal DHCP server. And fifth one is to serve the wireless client with the internal DHCP server. The DHCP server IP address must be configured, and that's nothing but we are configuring IP helper under the SVI. In my lab, I would be configuring management IP address, but if you have loopback IP address configured, you can configure that as a helper address under the client SVI. Okay, so this is my controller. As you can see, I have no VLAN 60 SVI configured, but I have created a VLAN 60. As you can see here, the name of the VLAN 60 is internal underscore DHCP. All right, so I would create a DHCP scope, but before that, let me show you if I have by any chance DHCP scope created. No, it's not. So I will configure DHCP scope. So let me copy the DHCP scope configuration. All right, so 60.0, this is my default router, DNS server. So copy paste. And then I would exclude IP addresses from this particular range, 60.0, 92.168.60.11. And I would also exclude another range. All right, so I have excluded and I have created a scope. Now I would configure SVI. So SVI 192.168.60.10, 255.255.255.0 IP help. So as I said, I will be configuring my WMI IP address as my helper address, but you can configure loopback IP address by creating a new loopback as a DHCP server. I'm just configuring my WMI IP address. All right. Okay. So WLAN 60 is created. I have configured. Okay. So access point login. All right. So I created DHCP scope. I configured SVI. I have configured helper. All right. Let's enable WLAN. So I would configure this SSID just for a better understanding. I would give name as Wi-Fi 256-DHCP, and I would enable this. Security is same. We have got PSK. Okay, just for a simplicity, I have enabled SSID. Let me show you the policy profile. So this is my policy profile. As you can see here, I have enabled this. The name of policy profile is Wi-Fi 256-policy. I have mapped the VLAN name, which is internal DHCP, which is nothing but VLAN 60. So looks good. Then I would go to tags. And this is my policy tag. I have mapped my Wi-Fi 256 -internal as a policy, WLAN profile, and policy profile as Wi-Fi 256-policy. Okay, so from the configuration perspective, all looks good. My WLAN is enabled, so I should able to see Wi-Fi 256 SSID. Let me see if I'm able to see. Other network. Yep, I'm able to see Wi-Fi 256-DHCP, so it looks good. So let me run a debug now. So debug wireless. Let me see if the debug is running. Show debug. It's not running. So debug wireless MAC. Okay, so debug is enabled. Terminal mon. I will enable debug on the access point as well. Debug client. Let me copy the MAC address. All right, debug is enabled on access point CLI as well. Now I'll do the packet capture. Wi-Fi 256 DHCP DSCP. I would give name int and then map the interface, 100 MB buffer size, apply. I would initiate it by clicking on start. So my pcap is enabled, my debugs are enabled on EP CLI and controller CLI, and it should be okay. Let me try to connect, but before that I'll enable the I'll start pcap on client laptop as well. All right, so let me connect my Windows laptop to this particular SSID. The name of SSID is Wi-Fi 256-DHCP. So I'm going to connect now. Let me enter password. It's trying to connect. All right, it got connected. So let me first see on the controller if I'm able to see the client connectivity. All right, so client got 60.12 as IP address. Let me see the client state. It's active. 60.12. It looks okay. Yeah, policy manager state run. Pcap also stopped. So pcap is there. I would export this pcap. Okay, DHCP underscore int is my pcap file which I would be looking into. I have got a debug output. So as you can see here, this is the debug file which we are going to analyze it, and we have got debug output from access point as well, which we will see in detail. So let's understand and analyze this. So as I said, we have already collected radioactive traces on WLC. We have collected embedded pcap. We have also got the AP client debugs, and then we have also got client side pcap. So let's analyze one by one and understand how does the traffic flow when it comes to internal DHCP server. All right. So this is my access point debug output, and then I have got client debug as well on the controller. So you can see here, this is also, so it's a DHCP discovery. You can see it's been initiated, and then you got, after that you got DHCP offer, DHCP request, and DHCP acknowledgement. I'll show you the debug analyzer tool which Cisco has already got. Like, you know, how can you parse the data when you dump the debug output. So I'll show you that as well, and then we'll walk through the pcap file as well, which is on the controller. We have got one pcap and the other one is on the client side. So let's first understand the controller debug. So if I log in into the controller, let me log in into the controller and show you exactly what I mean as a debug analyzer. So what I mean is, if you go to radioactive trace, you have an option called wireless debug analyzer. If you click on that, it will open the new page. So I have uploaded the debug output, and now if I click on parse, just click on show advanced debug insight, and you can see here my client MAC address is highlighted. If you got multiple clients, it might show you multiple client data, and you can see the summary of success session, the failed session, start time and end time. And if I go down and if I see my IPv4 IP address assignment, if I click on that, okay, as you can see here, you got IP address as 192.168.60.12. I have also got the flow here, the diagram which talks about initial wireless authentication or association frames, and then I have got DHCP, like, you know, the request and IP. I want to show you the AP debug output as well, because you can see here it's quite difficult to understand the debug output from access point as well. As you can see here, the AP debug output is like, you know, it's showing a DHCP ARP IPv6 or ICMP v6 or DHCP v6 messages here. It's quite difficult to understand the flow of you know, the messages in this log. So what I've done is I've tried to put it into the script and try to filter it out in a tabular format. So I try to use pandas, which is again the Excel in Python, I would say. I'll actually walk through basic of how the script is written. This is not a Python session, but let me show you exactly what I have tried to achieve out of that. So very first thing is the library. So I've got pandas library, I've got regular expression library, I've got date time, and I've got IP address as library. RE as a regular expression is used to search the specific pattern of the logs, or let's say the keywords inside the logs, which is very useful. Like for example, there are specific keyword like DSCP or ICMPv6 or DSCPv6. If you want to search those keywords inside the log statement, it is easy with the help of RE, or regular expression. Pandas, as I said, it is Python Excel, and it's kind of like if you want to get it very structured data from files like which I was talking, like files like this, pandas would be really good to get that tabular format of data. Then you got a date time, which is again to track the time and date. So that's why I have called that library. IP address is like, just to get validation of you're entering the right IP address. Because what I've done is I have put two inputs. One is the user should enter the IP address which you want to search inside this log file, and the protocol which you want to search. So if you, by any chance, if you put a wrong IP address formatting, with the help of library, it can be validated. That's why IP address library has been called. Now what I've done is, the next part is the function. Okay, so the next part is the function. I have defined the function, which is I'm calling the file which is inside that log underscore file. I have also got the target IP and protocol filter. So this is target. I have also got target IP and protocol filter just to get optional filter inside the function. If I open that function, as you can see here, I have got very first thing is whatever data I'm reading from this log file. So what is log file? If you see here, let me open this. This is my file. So I have got this debug output file. This file I have saved in this folder, and this file I'm calling it inside this function. All right. So let me open that. Let me go here. So once I call that log file and filter it out with the IP filter, IP address and protocol, that details I am putting inside the list called data. Okay. And then what I'm doing, the next section is all about reading the file. So I am reading the file, and with open, I'm trying to, once you run this code, with a command, what you're doing is you're trying to close that file automatically. So with open, I'm reading this file, and it is read only. And what I'm telling is try to get the re.match is regular expression dot match. So as I said, it is checking the specific pattern inside that log statement. So it might search a DHCP, ARP, ICMPv6.11. You can put any keyword. You can put any keyword here inside that regular expression log statement, so that it'll try to search that particular keyword. Now what I'm telling is, if match, once the regular expressions which are mentioned here is matching, it will try to put into this particular match.groups with this particular variables. All right. So from line 23 to line let's say 67 is all about parsing the data. And what I have done is I am trying to parse the data with the keyword called DHCP inside the message. So for example, here I could see there are keywords like DHCP, .11, ARP. So I just pick those words. It is not necessary that it is something you have to follow, but I've just tried to it is for my easiness. I have tried to do that. So I'm trying to filter DHCP. I'm also trying to filter ARP and ICMPv6, and also .11 related messages. Once I pass that with the help of, like for example, I'm putting the direction also. If there is a TX success, then put that as a separate column as TX, so that I understand whether the data is transmitted or received. The next block, which is from line 70 to line 78, it is just trying to filter if there is IP address match and it is a valid IP address. It will try to put that IP address inside the target IP as the variable. Okay, so after I put that into target IP as this particular IP address, after I filter, what I'm telling is protocol filter. So I'm trying to filter a next protocol, and whatever data I'm filtering out, I am appending that data inside this list, and this list is nothing but which I called here as an empty list initially, this one. So I'm putting all the data which I'm filtering out inside this, and then this particular code is talking about converting into the pandas data frame. So I'm putting all those details inside this pandas format, and this is the main block. So what I'm telling is program or this code has to run from this file directly. If you call this as a module in some other file, then it will not work. So I'm just insisting that this should run directly from this particular file. And then I'm calling this file and I'm telling, like, put a input as IP address, and then once that is matching, put that IP address. If it is not matching, with the help of IP address library, it is telling, I'm putting this condition that it should show me as an invalid IP address, and then same goes with the protocol, and then I'm putting everything in the CSV file. That is it really. It has got mainly 3 blocks. If I see, first one is library, second is function, which talks about parsing the data and filtering out the data. Yeah, and third one is the main block, which is just making sure that you're running this block directly from this file, not calling as a module. Okay, so if I run this, I have already got the file name mentioned here. So if you see, this is the file debug output. You can see here, this is the debug output file name. So if I call now here, I'll put the IP address as my client IP address just to filter it out, those logs. And then I'll put DHCP. And you can see here, I could see only DHCP offer and DHCP acknowledgement. Now, why is that? Because I somehow try to miss the DHCP discovery and DHCP request packet, and that's why I'm only getting DHCP offer and DHCP acknowledgement. And that's why it is showing here those details. All right, these are all TX, as you can see here, right? I think this is just to get idea about whether I'm able to get debug output properly, and in this case I haven't got the proper debug output, especially on the AP console. Probably next, when I'm covering DHCP option 82, I would run the same and I would try to get the full capture or full logs where you can easily analyze, or we can understand whether the script works fine. But yes, this is giving me a quite summarized way of understanding whether I have all the DHCP packets which should be part of this log file. All right, so this is from AP console. We have checked from the controller debug. We have checked the AP debug. Now let's understand the pcap file. And the pcap file, let me open. Okay, so this pcap file is from the controller. And if I want to understand, let's say DHCP first, I'll filter it out with the DHCP, and I can see there are multiple packets going back and through from client to the controller. My controller, as you know, the IP address of VLAN is 192.168.60.10, and the management IP address I have configured as a helper, which is 192.168.40.230. Let me do proper filter so that we understand the flow. So first I will do a capture. I'll do a filter of CapWap and DHCP. So, like, I just try to filter all those packets and just get a proper flow to get more clarity on whether I have all the packets covered. So as you can see, very first packet is, and by the way, this is on the controller pcap, which embedded pcap I have got, right? So this is my client MAC address, as you would have noticed. This is the, let me show you that MAC address. So this is the MAC address 9CB6D0C13889, and source IP address is 0.0.0.0, and destination IP address is 255.255.255.255, and this is inside the CapWeb tunnel. So if you see here, let me show you in my PPT which I was talking initially. So let's understand that. So here if you see very initial packet which is about discovery. So this is 0.0.0, 255, 255, 255, 255. When it hits to access point, it encapsulates that inside the CapWeb, and this is what I'm showing here. So this packet is encapsulated inside the CapWeb. You can see here 5247 is my CapWeb port number, UDP port number. 30.11 is AP IP address, and 40.230 is my controller IP address. Inside that, this is my discovery packet. If you want to see a type of DHCP message, is a discovery. Yeah, it's a request. Message type is boot request, so it's a discovery packet. Now, after that, this is the packet again from controller to the access point. So which I am referring, let me show you that here. So offer, let's go to offer now. Yeah. So this is my offer, and source IP address, you can see it should be 60.10, which is my SVI, and destination is the actual IP address which controller is trying to offer to the client as a DHCP server. If I see this second packet 60.10, right, I've mentioned here. So 60.10 is the source, and destination is 60.12, which is my client IP address. And inside that, if you see here, my DHCP server identifier is 40.230. And why is that? Because I have mentioned that as a helper address under the SVI. That's why the server identifier is shown as my controller management IP address. In your case, if you configure loopback, that might show as a loopback IP address. Okay. So this is about offer. Then the second packet is a request. You probably can imagine the request packet is again going from client towards the controller or towards the DHCP server. So if I see here, third packet is 30.11 as a source IP address, 40.230 as my controller IP address outside, which is my CapWeb header. So let's go to DHCP request and understand that. So this is my DHCP request, and this is what I have shown. So 0.0.0.0 is the source, and destination is broadcast. Now the offer, the DHCP offer has already given as 60.12. Where is that mentioned in the request packet? Is this option 50. And here you can see the requested IP address is clearly mentioned as 60.12, which sounds correct, right? This is what the IP address is expected to be handed over to the client. And that is what the client is trying to confirm with the DHCP server. All right. So this is third packet, which we have already covered. So if you see here, now once it hits here, it decapsulates that packet, and then it goes back to DHCP acknowledgement. Now let's understand DHCP acknowledgement. So DHCP acknowledgement again from client SVI, which is 60.10, and the destination IP address is 60.12. So this is what I have shown, right? The 60.x destination is nothing but the client IP address. Okay. So the acknowledgement is given, after the acknowledgement, you can see it's like, after probably 3 minutes or so, you got a DHCP inform. This is just, client might be requesting additional information, like here the details are mentioned, like request list. It might be asking for additional information because client has already got the IP address as it is mentioned here, right? And then you got acknowledgement that, okay, whatever data you suppose or you're requesting, it is already there. Router IP address, DNS server IP address, subnet mask, DHCP server identifier. So this is how the handshake has happened. And by looking at this, I think it is quite straightforward that our DHCP process is successfully completed and client has got 60.12 as IP address. All right. So this is a WLC pcap. Let's understand client pcap probably. Yeah. Let me open that file as well. And here I don't need to filter 5247 and 5248 because this is a pcap from client end, right? Again, as you can see here, this is the flow, like for example 17. If I mean, it is very important to see the timestamp because you may need to correlate the time and the the handshake like a DORA process. So if I see here 13 like 9:38:13 and after that straight away 9:38:17, probably this is the second discovery packet because I haven't got any response from server. So after some time client has initiated again discovery. This is from the client side pcap. So I would start from here, this as my reference point. All right, and if you see here, then after that I got offer from controller as 60.12, and there is no cap up here. Obviously it's a cap, it's a client side pcap, right? So it's the same like what details we saw inside the cap app, it will be same. And then you got DHCP request, DHCP acknowledgement, and the ACK packet which we saw, sorry, the inform packet which we saw, it's the same here. And then you got acknowledgement for the inform as well. So it's pretty straightforward. From the pcap perspective also it is showing there is a proper the DHCP process successfully completed. Another thing probably I can show you as a bonus point, statistics, then flow graph. As you can see here, this also gives you a clarity about the flow of DHCP, right? You can see the transaction IDs. Okay, so you can see here it is a flow graph, and you can see there is a destination IP address mentioned. Then if you see DHCP request also is a broadcast. Then you can see DHCP offer source IP address is 60.10, destination is 60.12. It gives you more clarity in terms of how does DHCP packet, how the DHCP packets are going back and through from client to the controller as a DHCP server, right? I think that is it really I wanted to cover as a part of the analysis. I hope you have got more clarity from this particular video. I'm going to cover even option 82 in the upcoming videos, which will have more detailed information with the external DHCP server. But yes, I think that's it from this particular topic. Thank you.